all about you, Camtasia.
You want to just cut that part out? Or you want to start over?
Ready and go.
All right, so section 5.5, law of signs. First, we need some background info, and it's actually going to be background info for 5.5 and 5.6. So if 5.5 is a little longer than 5.6, that's why. We're setting up the stage for both. Basically, we talked in chapter 4 about right triangles.
That's a lot of chapters going on right now, but yes, you are correct.
In chapter 4, we talked all about right triangles. Hey, guess what? Not all triangles are right.
No! What?
I know.
Ay,
Some of them are this other word called oblique. Oblique triangles are triangles that have no right angles.
Are you making this up?
No, I'm not. It's
Are you?
really,
Do you promise?
I promise.
Is it on Wikipedia?
I don't know.
Everything on Wikipedia is true.
I don't know if it's on Wikipedia.
Okay, all right.
Without a right triangle, we cannot use SOHCAHTOA to find the missing sides or angles. We can't use the fact that sine of the angle equals opposite over hypotenuse because we don't have a hypotenuse because we don't have a right angle.
It only works with right angles.
Right. So, and here's 2 examples of what those oblique triangles can look like. A couple of examples. So, what we do is we have to come up with something else. So the triangle congruence stuff we did in geometry. This
Way
is
back
kind of
when, last year.
An introductory thing. We talked in geometry about how there's 4 types of triangles that you can say are always going to be congruent if you know this information.
Right.
So if I know an angle, and a side, all triangles with that angle, and side will be the same triangle.
No matter what.
Okay, same with angle, side, angle. So angle, side, angle.
Doesn't matter how you twist the triangles, this is what it does.
If it has that angle, side, and that angle, it will be the same as all other triangles with that angle, side, angle.
Right.
Side, side, side works. Side, angle, side works. And so for...
Angle, side, side, though.
Right, and I'm not going to write it out. I'll write it backwards. What we talked about in geometry is that this one does not show congruence.
No.
Okay, and we'll talk more about that case in a little bit.
That is correct.
For angle, angle, side, and angle, side, angle. And sometimes with SSA, we can use what's called the law of signs to solve the triangle. That's weird that that showed up twice. Okay, well, sorry about that. It's not twice on yours, I don't think, but it's twice on ours. Here, down here is the law of signs. You can write it either way with either the signs on top or the signs on bottom.
The ratio is what's important here.
Right, that the sine of angle A goes with little a. And the way you set up the triangles is the angle A, we use capital letters for angles, and then across from angle A is little a. Across from, this would be B. Across from angle B is little b.
Just like you did in geometry.
Angle C is little c. And the C, big C, little c gets a little tough, but they use the alphabet, so what are you going to do? So, what, you want to just jump in and try a problem?
Let's go for
jump.
broke. Jumping.
Oh.
Let's hide. Do some hiding.
Do some hiding. Okay, example 1. Solve triangle ABC given that B equals 15, C equals 39 degrees, and B equals 52 degrees. This is angle, angle, side, so we can do the law of sines. So what we're going to do is,
once you set it up, you'll also know if it's going to work.
Right. I like putting sine on top.
You know, whatever.
Okay.
I don't have a preference. It's all math.
Okay, so sine of angle A over, we don't know side A, equals sine of angle B, which is 52 degrees, over side B, which is 15, equals sine of angle C, which is 39 degrees, over side C, which is this one over here. Now, I put in a variable here we actually can figure out really quickly without actually using some fancy new thing. Use a fancy old thing, 39 degrees plus 52 degrees plus angle A has to add up to 180.
I'll just punch it in. 180 minus 39 minus 52, carry the 7, multiply by 36, 89.
He was kidding about those last couple of steps. So instead of having a big A there, we can say A is
your mama.
89 degrees. No.
Oh, okay, sorry. No, your mama jokes.
No. So where this A is.
Wow, that was a smudge.
Where that A is.
That was like a fingerprint on the door.
89 degrees. And
okay.
now.
Oh, can I?
Yeah,
look,
go.
if you'll just like check this out, we can solve for the 2 remaining variables, which means that law of signs is going to work.
Yeah. If we can't, then.
If we can't, law of signs won't work.
Right, but what we're basically going to do is look at this separately. We can look at this part of the law of sines right here.
Right.
Cross multiply.
Right.
And then solve for a.
Right.
So a times sine 52 degrees equals 15 sine 89. Put this in so that you don't end up rounding. Do 15 sine 89, enter.
Divide
by sine 52, so that it does answer divided by sine 52.
We want to be as exact as possible,
As
but we're getting
exact
decimals.
as possible.
And you should get to the 100th decimal place exactly what we get. And if you don't, you truly do have a rounding error issue. So
100th or 1000th?
1000th, what did I say?
You said 100th.
1000th, third decimal place. So 13.075, or if you round up 6. Those are the only
5
two
or
things it could be.
6.
You cannot have 13.08. That is incorrect for this problem.
Right, because, yeah, there's no reason to round. Now we would use the other part of this. Let's do a nice, how about spring for our color?
Spring. Do the other side.
Do the other side. So cross multiply here. C sine 52 degrees equals 15 sine 39 degrees. Hey, by the way, I hope your calculator has been in degree mode this whole time. Otherwise, this is not going to work out very well.
Need to have positive numbers here. Positive numbers. Is that sine 39?
Maybe. Yeah.
Yeah.
Sine
Okay.
15.3.
What?
15 sine 39 divided by sine 52.
Gee willikers. 15 sine 39.
Right, because we divide by sine 52 on both sides.
52. 14.652.
14.652
Or 14.653.
or 3.
Okay, rounding according to AP standards.
Right. Round or truncate. So we knew 3 things. We now have solved 3 things. We know everything for this problem.
For this problem.
Right. So
Okay,
there's
good talk.
example 1.
Good talk.
Go ahead. Go ahead. Go.
All right, I'm on it.
Hey, example 2.
Another using law of sines. How do I know I use law of sines here?
Well, angle, side, angle.
Wait a minute.
When we know 2 angles, we definitely are going to have to use
And there's
law
no
of
right
sines.
angle.
There's no right angle.
You know, we could use the right angle, though, because the sine of 90 degrees is 1. So we could use
law of sines when we have right angles,
yeah.
but it's just repetitive.
I agree.
There's an extra step.
I
Okay.
am not arguing.
Okay,
this.
okay.
Yeah, I'm just saying if we wanted to.
If we wanted to.
Yeah, if we wanted to, demonstrate our uber nerdiness.
Right. So we don't know what A is right now, but we can find it because, hey, 70 degrees and 34 degrees, just subtract that from 180.
It's 34 minus 70, subtract 39, carry the 17, 76 degrees.
Okay, so A is 76 degrees. Just,
Just
that
in
looks
case.
kind of like a plus or
JK.
minus. What did I...
That's actually what is going on there?
There we go.
Okay, all right, perfect.
Okay.
You got the top of that circle
sine.
off the
It's
page
okay.
there. Okay. all right.
Sine of A, 76 degrees, over little a, which is 33, equals sine of B over
Little b.
little b, which we don't know. And
What?
equals sine of C
70.
over little c.
Little c.
Itty bitty c. Okay, and then we're ready to solve. So this one's just a little bit different. Like, we're still going to use the first 2.
It's the same but different.
Yeah, we're going to use the first 2 to find B, but then to find C, use this one that we know.
You always
with
use the one
this.
you know. Every
Yeah.
time.
If we will find B, and yeah, we could plug it in and then use that to find C, but what if we mess up on B? Then we also mess up on C.
And now we're in trouble.
And now that's almost the whole problem.
Almost.
So sine, what do we do? B times sine 76 degrees equals 33 sine 34 degrees. So we're doing 33 sine 34 divided by sine of 76.
I got 30.841 or 842, depending on your AP rounding, truncating or rounding at the third decimal place.
Okay. And then we are not going to use the middle here. We're
No,
going to
don't
use
use the middle.
this and this. So this, you may need to rewrite it to be able to see it. It depends on just how visionary you are.
I'm totally visionary.
Okay, C times sine 76 equals 33 times sine 70. So divide by sine 76 on both sides to solve. Is he just saying, come on,
Mr.
snow?
You didn't hear this, but Mr. Duke just wandered by the classroom cheering for snow, actually.
Yeah.
Come on, snow. So I get 45.112, and that's all you're going to get on that one.
Yeah, 45.112. We got A, we got B, we got C, we're done.
Yay! Dunskies. Hey kids, winter storm warning version of law of cosines.
Law
of sines.
Law of sines. So that's actually our code word. Code word. How about hey baby, it's cold outside.
Hey baby, it's cold outside.
I'm writing it. No, yeah, the song, like.
Dude, yeah, that's the only part I know.
Hey baby, it's cold outside.
Baby, it's cold outside.
I like that Christmas song. Anyway, let's get to the math.
Okay.
So triangle congruence review continued. So we already briefly mentioned this, but we're going to go into more detail now. That the side-side angle case doesn't actually mean that we have a certain triangle. There's actually 3 different cases we could have. If we know a side to side and an angle for a triangle, either that could actually not be a triangle at all, or there could be one triangle that exists with
Or
that.
hey, mind blow.
Could be 2 triangles.
How about that?
Which is pretty crazy. Like there's a whole like one of them ends up looking like this, and the other one ends up like looking like this kind of a situation.
Yeah, like crazy.
But triangles.
But much better,
nicer
clearer,
than that.
clearer.
Yeah.
Yeah.
So here's how we figure out how many triangles they are, and it can be kind of complicated.
Mm-hmm.
Okay, but we just have to get used to this idea. You're going to be given, because it's side-side angle, an angle that we're calling big X and 2 sides, little x and little y. Notice that we have a letter in common. We know big X and we know little x.
That's helpful because that gives us part of our ratio for a fact.
Right, that's the one. And so, like, if we were setting up law of sines, we know sine x over little x.
We would have that decimal answer.
Yeah. So what we do is we look at the sides here, and I have it set up in a flow chart as well. If you like flow charts, you know, because some people think flow charts are cool.
Mm-hmm.
I think I'm one of them. So if you want to use the flow chart instead, but here you go. You check and see, is x bigger than y? If x is bigger than y, then or if x equals y sine x. But normally this is what we're gonna see. Okay, that x is bigger than y. That means one triangle exists.
Just one. That means there's only one way to do that. You'll get errors all the other ways.
Right. So if x is bigger than y, we just solve it like we would solve any other law of sines problem. It'll be a little bit different, just slightly different, but not too bad. Okay. So if x is less than or equal to y, or if x is less than y, there's these 2 situations that mean we have to check something else. If x is less than y, we have to check and see, well, what about y sine x? We actually have to figure out what is y sine x and then compare that to x. Because if x is smaller than y sine x, that means no triangle exists.
Right, and you'll be able to tell that, believe it or not. Once you get going, you'll be able to tell, like, I can't get a triangle.
Yeah, yeah. And then if x is bigger than y sine x, then that means 2 triangles exist, and then we would solve and find out what both of those triangles are.
Right.
So, and the flow chart says the same thing. It says, you know, like you would say, okay, which is bigger, x or y? So then it tells you, like, that tells you which direction to go here. If x is bigger than y, one triangle exists. If it's less, you have to check this out and then see what happens.
Right. Now, the reason this works this way is because if you look on your circle card from 0 to 180 degrees, you can get the same sign, S-I-N, in 2 different places.
Right, because like over
If you look at, like,
here,
say, yeah,
this point
has the same y
has
coordinate.
the same y coordinate as
point.
This one over here.
So that's where you're checking both
The
of
x
those.
values are different because this would be a positive and this would be a
Right,
negative.
right.
But basically, yeah, what's happening is that we have 2 different places that give us a
Possibilities,
certain
right.
angle.
And so you have to check this because when you use your calculator and you hit inverse sine and put your number in, what's going to happen is
You get one answer.
you only get one answer, and that's why you have to look at this flow chart and figure out, okay, is there Right.
there something else going on?
Yep.
So let's give this a try. Let's solve some of these.
Let's have a gander at this
This here
single
example.
side.
SSA, side angle. Okay.
Single.
So if we drew the picture of this, well, that can be tricky because we don't even know if this is really a
Yeah,
triangle.
we don't even know if it works.
But because we know, well, we'll just
Let's just dive in.
Let's just, yeah,
All right.
let's see what happens. So remember that on our previous slide we said that if we know the angle and the side, this is gonna be the big X in our like flow chart situation. This is the little x.
Because they match. Angle
they
A,
match.
side A.
Yeah.
Okay.
And that leaves this to be y. And so when we're comparing, we have to start off by like labeling those things
Right.
to know, like if I compare x and y, well, without labeling them, I don't have an x and y.
Right, it just becomes harder.
So which is bigger, x or y? Well, x is 12 and y is 22, which means x is less than y.
Right.
So there's two situations that could be happening. We need to keep going, keep checking. We need to see what about x and y sine x. So x is still 12, y sine x is 22 sine of 54 degrees. So in our calculator, we need to figure out what is 22 sine of 54. It's
17.798.
17.798. So 12 is less than 17.798. Since both of these are less thans, if you look at your flow chart, that means that no triangle exists that matches up with this.
So there you go. So see, we
No
couldn't even draw a triangle to begin with.
We can't draw a triangle like that to begin with. So example 4. So let's see what happens on this one. So we
Go to pen. Go to pen.
it is on pen. I
All
kept pressing that extra button. This would be our angle x that we know. Here's our little side x, or our x.
There's the y.
Yeah, and this is y. So let's compare x and y. So x is 17, y is 12. That's a greater than situation.
It's only one way.
So that means that one triangle exists.
Just one. Now we run through the whole law of sines situation and
solve it.
Solve it out.
And we are going to go ahead and solve it because this is a little bit different because of what we know. So
right.
sine of angle A.
Yep.
Because we do have an ABC situation here. We don't know either of those two parts, equals, we don't know sine of B over 12, and then sine of 26 over 17. Normally we know two angles and we can solve for the other angle, but now we don't.
Right.
We have to start off with this right here and cross multiply and figure out what this angle B is. Because we don't know anything from this fraction,
nothing.
so we can't do anything with that fraction right now. So if I cross multiply here, 17 sine B equals 12 sine 26. And so we divide both sides by 17 to solve for sine B. Now we say, well, how do I get rid of the sine in front of B? I have to take the inverse sine of both sides, which is why sometimes we get two triangles, because inverse sining sometimes has more than one answer. That can be true.
That's right.
But
So
we already figured out there was only one triangle.
Right.
So.
I'm going to punch this in real quick. So sine of 26 degrees.
And he's putting it all in at the same time. Like he's typing
inside the stuff.
Inverse sine, and then he made a fraction in here.
That's the best way to do it. It's the most accurate.
Yeah, because there's no rounding.
There's no rounding issues.
Or if you keep doing answer and then moving with your answer, that also helps.
I got point 3.
I feel like we want it to be in degrees.
I got degrees. Let me just change the settings on my old document here. 1 second while I sort this out. $18.025. That sounds a lot better.
B equals 18.025.
Yep. Then that's the length of your side B.
That's the angle B.
Oh, that's what I said.
Yeah, that's angle B. And so then we can figure out what A is, because now 180 minus what we just got.
Whoa, no way.
Minus
180 minus
26
That's
is
insane.
angle A.
$135.975.
Well, that's quite a large angle. So angle A is 135.975. Angle B is 18.025.
So there's, and we know C already.
Yeah, so we need to find little a. And so since now that we know what this is, we would basically plug it in there.
And solve it all out again.
Right, using a cross multiplication thing with this fraction And let's use the one we know just in
Yes.
case somewhere we messed up.
Always use the one you know. Never use a decimally one. Always use the one you know.
And
Because you can type it in exactly into your calculator and reduce rounding issues.
Right.
By reduce, I mean
Like there will be smaller
Right.
rounding issues. A times sine 26 equals 17 times sine of 135.975. And so you divide by the sine of 26 degrees on both sides. And A equals
26.95.
26.95.
And ask yourself, does that make sense?
1 or
951.
0.
1 or 0, yeah. 26.95, 1 or 0. Does it make sense? I mean, one of the first things you have to understand about triangles is two sides have to add up to be greater than the third.
Right?
So
that's a very important thing, actually.
So if you're working this out and you get A to be 72, you have an issue because 12 plus 17 is not that.
Yeah, 12 plus 17 is 29, which is bigger than this, so this does look like it's true. Also, the biggest side is always across from the biggest angle, so since this angle was big, this side should be bigger in proportion to these.
So a couple of old triangle tricks from geometry
Right.
come in helpful here.
And there were some units on here, so technically this is miles, although...
Is that miles? Okay, yeah, we're miles.
I mean...
We were kilometers a minute ago, so that's what your ending units should have been, but we didn't have a triangle.
So no big deal. Pronounce it. Example 5. Solve the following triangle. So again, we're doing this whole...
Here we go. X larger than Y business. What are you doing? You gonna start working this problem out?
Angle X, so this is little x, this is little y. So compare 31
and 34.
And 34. 31 is less than 4.
It was this morning. Now you might need to check it again tonight.
31 is less than 34, so now we have to check x and y sine x. So x is 31, this will be 34 sine 52 degrees.
52 degrees. Lunch bell. 34 sine 52.
Degrees. There you go.
26.79.
0.793 or 4.
Yeah, but we just basically need that 26 part. So x is larger.
That's a bigger than situation, which means two triangles exist.
Shut the door.
The front door?
The front door.
Okay. Yeah, so we have to find both of those triangles. This could be tricky. I'm going to get rid of this real quick.
Yep,
we're going to need all the room that we can get.
We need some space because basically what we're going to do is law of sines.
Twice.
Like, not just twice, but like 4-ish times because we've got to find all the missing pieces.
Yeah.
So
what's important is our two triangles that we have share angle B, side A, and side B.
Right.
But each of them also has an angle A, and so we can call our angle for our first triangle angle with a little subscript of 1.
For the first angle?
Yeah,
and
then an angle with a subscript of 2. Oops, that's not a very good equal sign. For the second one, so that's one thing we need to find. We need to find angle C for each of our triangles. I'm going to put an angle sign there because it's hard to tell C's apart.
Right.
And then we need to know little c.
Little c.
Little c. So side C for each of them. So that's 6 things we're finding. Normally we find 3, but we have 2 triangles, so we have to find all of these.
A lot of law signs going on right here. A lot of law signs.
Okay, so we know sine of 52 degrees over 31. That's big B and little b that goes together. And we need to find sine of A. We're going to find A1 first
while
because
Mrs.
it's
Stevenson's
the first
talking,
one.
I'm going to disappear my calculator. It didn't. I thought my calculator ran out of batteries. Never mind.
Oh, okay.
I was going to go look for a plug, but
Okay.
it says it's good. So
We cross multiply here and we get 34. No, we don't. We get, okay. 34 sine 52. I was about to, though, write 31s or something weird. I was about to write the wrong thing. Okay, and we solve, so we divide by 31. And this is the whole situation where when we do inverse sine, our calculator tells us one answer, but there's actually, in this case, more than one answer that fits this triangle.
How crazy is that? It's really crazy. So let me.
Super crazy.
Yeah. one might say. So hold on. It's all good, Mrs. Stevenson. It's
Oh,
all
I
good.
see. I see. Yeah, that's totally going to work out.
59.799 for angle 1. Now,
59.799.
think about your unit circle for just a second. What value in second quadrant gives us the exact same reference angle measure?
Well,
we would have to start at 180.
we have this angle right here is 59.799, but the other one
Is also 59.799.
So what
but
we have to do is
short of that. So
yeah, we have to do 180 minus
180 minus that, which is 120.2. Now you can get some. It's quite possible you'll get some really interesting angles when you do this. Like really interesting.
Interesting being a relative term. What is
Interesting to us. 120.2.
And then there's two zeros.
Yeah, 2 zeros or 0,
or
1.
0, 1.
Just depends on your rounding or truncating.
Okay, this is angle 2. And so we drew out the triangle, but it's going to turn out that every single time you find angle 1 and then you do 180 minus that, and that's angle 2. Like you don't really have to draw those triangles. That's just us telling you why it is that way. So I could
BT Dubs, this is a difficult topic. You may need to watch a couple times.
Yeah.
And for sure ask questions.
Yeah. So let's fill in what we know up here.
Yeah, let's do.
59.799 degrees. And then we've got 120.201 degrees.
Yep.
And now from here, we do law of sines with the first one, and then we do law of sines with the second one. And like do those separately. So right here, we can find this angle C by doing
180.
180 minus 52. Which was our original angle they gave us, angle B. And also, we need to minus 59.799.
68.201.
68.201.
Yep.
Is angle C1. And then for, do you want to do side C1? Or
Let's go ahead and find that other angle because it's not a hard step.
Okay, so angle C2, we also do 180 minus 52, but now let's subtract our angle 2, which is 120.201.
7.799. Now, here's the deal.
Is this what you mean by interesting?
Yeah,
like that's
we got a really
small
small angle. Now, the thing with this is when you're doing your double checking, it's possible that you might think you have a two triangle situation, but something quirky happens with one of your angles.
And what should happen is right here we should get a negative,
Yeah,
right?
negative number. Or
if there's not really two
right.
triangles, you should end up with something not working out
Right.
once you try to
Right.
find the second triangle.
So, you know, if you're
double check these.
Yeah, if your pre-calc senses are tingling, double check your math and then go from there.
Kind of like your spider senses tingling?
Yeah, like spider,
Your
but
pre-calc
more
senses
important, your pre-calc
tingling?
senses, yes.
Interesting.
Yes, yes,
Okay.
indeed.
So to find C1 here, we need to set up our law of sines. So
use what you know.
use what we started with. Sine of
52
degrees
over 31.
over 31 equals sine of 68.201 over C1. Cross multiply and solve that. So divide by sine of 52. I put an equal sign there. That should have been a multiplication situation. C1 times sine 52. My bad.
Wait a second. Don't we have something 31? I forgot my 31. Hold on.
C1 equals 31 times sine 68.201 divided by sine of 52.
36.526.
36.526, and that's meters.
Why would it be meters, Mrs.
Because
Stevenson?
the original problem gave us that as units.
Always look at your units, kids.
And then we do law of sines again.
Again,
one more time.
Once or twice is never enough. So.
Same starting ratio here.
Yeah, always use what you know for a fact without any rounding errors.
And then sine of C2, the angle C2.
7.799.
7.799.
Divided by C2.
C2. Cross multiply, so that should be 31 sine 7.799. C2 sine 52. So divide by sine 52 on each side.
By the way, and we had an issue earlier on my calculator. If you get an answer, you know you should get a number, and you get an answer that's really wacky, make sure you're in the right mode.
Right, this is degree mode.
So 5.338.
338 meters. And, you know, we had a lot of work here, and that could have gotten pretty hectic, and to you maybe this does look hectic. This isn't a terrible situation to me, like if I had to grade this, but I mean, to be honest, it's not real fun. So make sure you're boxing your answers, or this actually is a really good way of writing it, is like where you just like summarize your answers, you know, in some place. But also, like, if we did this much work to get these answers,
you should probably do about the same amount of work.
You better have about the same amount of work. Like, just because you can do all this junk in your calculator doesn't mean that you don't need to write it down.
Write it down so you can get organized.
You know, sometimes we put the wrong thing in our calculator even if we know what we're supposed to put. And so we can't get partial credit if we don't have something written down.
Right, that's correct.
So this was Mr. Hazelwood and Mrs. Stevenson bringing you 5.5
Winter Storm Edition.
Winter Storm Edition.